So a function, by all intents and purposes, is when you are given a piece of information and then it is acted upon by a scenario. That scenario then causes a new thing to come out. Those of you that were here in 3rd grade, Noah, were you here? Jesse, you might have been here. I think they drew it something like this. Very simple. If I have a 1 and then I add 1 to it, what comes out is a 2, right? Totally simple, nothing difficult. If I have a 4 and I add 1 to it, what comes out is a 5. All right? That, in 3rd grade terms, is functions. And the whole purpose of this is to help you understand how functions work. Okay? A few things I want to share with you. The post office example that they have for you is a very good example of how the cost of something is a function of the weight. So the weight based on a certain cost will give you the total cost. So again, this is a function. Let's just say I have a 1 ounce package and it's 16 cents per ounce. I know the cost to mail that package is a 16-cent cost, right? That is how functions work in the real world. Now, in Algebra 2, we start to learn some different things about functions, and by definition, a function is a corresponding, and I'll use the word relationship, between two sets of numbers. Okay? A relationship between two sets of numbers. If I kept going with this really simple one up here, eventually you would have been able to figure out that the relationship is simply to add 1. Okay? And it kind of depends on how many you give. Like right now, 1 ounce package is 16 ounce. That's not enough data for you to be able to figure out what the rule was. But if I give you another example, you would probably be able to figure out that it's a relationship of weight times cost, and that'll give you the total cost. All right? So functions are corresponding relationships between two sets of numbers. Now, they draw it using a blue circle, which they call the range, and then another circle, can't find my red pen, which they call the domain. Okay? And they put some numbers in the domain. They've got 2, 1, 0, negative 1, negative 2. 2, 1, 0, negative 1, negative 2. And then 4, 2, 0, negative 2, negative 4, negative 2, negative 4, it looks like. You can probably look at this and see that what is causing this to happen is simply a double, right? Multiply by 2. Multiply by 2. And that gave you the range. Okay? So the domain is kind of like the input. And then this little section here is the machine or the rule that gives you this output. Okay? So the simple example up above, the domain would be the inputs and the range would be the outputs. Let's keep going. All right. Please don't get scared of this. Example 1, we're going to graph a function. so that you're able to figure out what happens if you use a certain number for the input, what will you get as the output. Let me break this down for you. For the given function, with a domain of these numbers, what will the range be? And then what will the line be? Okay? That's what they're asking you there. Now, the first thing I would do is I would graph it the way they did it. The domain is the x values. Okay? To break it down to what we're used to. The domain is the x values. And they've said the domain is 1, 2, 3, 4, and 5. The function, or the rule, okay, again, I'm just trying to make it simple. The rule is 4x minus x squared. Okay? So when I take this and I plug it in here, I get a specific range, which in our brains is a y value. Okay? So if I plug in 1, I get 4, 1 minus 1 squared. So 4 minus 1, and I should get a 3. Okay? If I plug in a 2, so 8 minus 4, I get a 4. Okay? And so on and so forth, right? You guys are seeing all these, how they're working. 4 times 3 minus 3 squared, so 12 minus 9, 12, 11, 10, 9. Did I get another 3 there? 4 times 4 minus 4 squared, I get a 0. 4 times 5 minus 5 squared, I get a negative 5. Is that right? Okay, so the domain is this, the range is this, which means if you wanted to translate it into x, y coordinates, which is what you're going to need to graph it, the first pair would be 1, 3. The second pair would be 2, 4. The third is 3, 3. The fourth is 4, 0. And the fifth is 5, negative 5. Okay? So what they're saying here is for this scenario, when I plug in this domain, what do I get and what are the coordinates? All right? Now, they've started by graphing it there, and I'm going to do that graph really quick. Over 1 up 3, over 2 up 4, over 3 up 3, over 4 up 0, and over 5 down 1, 2, 3, 4, 5. Somewhere over here. So if I were to connect this, it looks like a parabola, which if you were to continue it, I would bet you that numbers over here also satisfy this scenario. Like if I said 0 for my x value, my y value would be, maybe it's 0. 4 times 0, no, it wouldn't be that. But in any case, it looks to me like there's probably more values over here that work, but they only gave me these 5 numbers to sample and to work with. Okay? All right. So they give you some more information. What is the range? The range is these numbers here. The graph required us to arrange them in an XY pattern in order to graph, okay? In order to graph it. So the values of a function are the members of the range. I also like to think of them as output, okay? Those are the values, all right? let's see. Functional notation, right below the example. The values are members of its range. To indicate this, you use something called functional notation. F of 2 is 4. The value of the function when you use a 2 is 4. Okay, is what they're saying. Okay, so if I take this, the result of inserting f to be 2, that is x, is 4. That is your y. And this can be a little bit tricky for people, but just keep in mind that when they say f of a number, they're usually going to say f of x or f of q or f of something. Whatever this is usually your x value, okay, if they say it that way. All right. We're going to use that here in example 2. Here's example 2, guys. Here is a function for all values f. X (2x minus 1). And another function they're calling g, x squared plus 1. Oops, I forgot to write my x squared plus 1. Okay, you can all see that there. So there's two functions here. And what if I tell you to solve the value for the f at 2? Okay, this is A. F at 2. This means replace the x with the 2. Okay, this is A. So 2 times 2 minus 1. Okay, so the result, the value, or the output is 3. Okay, letter B. Find g of 2. I'm not going to use this one anymore because this is f. I'm going to use the g function. G of 2. So I am going to replace x with 2 in the g function. So it's 2 squared plus 1. There's my value, otherwise known as my output. Okay? That's B. Letter C. Letter C says the f of A, which means replace x with the letter A. So in the f function, 2 times A minus 1, 2A minus 1 is the result. Okay? That might not seem normal or even useful, but the goal here is just to teach you how to do it, how to use them, not necessarily for you to get excited about it. Here's where it gets tricky. D and E. D. F of G of 2. Okay. First you have to solve what G of 2 is. Okay, G of 2. That is 2 squared plus 1, which is 5. Okay, now you've got to solve what f of 5 is, because you take the answer and you plug it in because that's what G of 2 was. Okay, f of 5 would be 2 times 5 minus 1, which is 9. Okay, do you guys get the idea how you have to work from inside out? Okay, E isn't much different. It has us working from the inside out.